All right, good afternoon. My name is Larry Chang. I'm the coordinator for the BEST Center, and I'll give a brief explanation of the BEST Center's mission and why we're here today. But welcome to our presentation, Building Automation Systems, a Green Career Pathway for ICT Students. I don't know how many of you might have been in the previous session by Stephen Wright, where he was kind of giving us the 10,000-foot view of possible employment opportunities for ICT students. So that is a large part of why we're here today, to talk about the Building Automation Program as being one of those pathways for a hybrid entry-level technician job. All right, just briefly an introduction about the BEST Center. Right, we have been a national center for a little over a year. We're funded by the National Science Foundation, very similar to MPICT. And we have been the previous recipient, or I should say specifically, Laney College has been the recipient of 2 previous NSF project grants related to curriculum development, and the Building Automation Program was one of the deliverables from the second grant. We're headquartered over at Laney College in Oakland, but we have a number of co-PIs that help us with our team efforts, really to prepare technicians for their critical roles in managing buildings so they operate at optimal levels for energy savings, while maintaining, again, the traditional goals of comfort and safety. You'll see that our mission is 3-pronged. Right? We definitely want to help advocate and advance the critical role of building technicians, and how they are really far more than just kind of maintenance people, but actually are segueing into a very important role as energy managers. So we want to also continue to put it in the public's mind that our goal is to create high-performance buildings, right? Previously, many of the buildings you might see in San Francisco and Oakland and elsewhere, right, don't have systems in place where you can actively see what's going on inside your building. And that's really a huge detriment, especially if you're trying to capture energy savings or even just maintain the comfort of your occupants in a good day-to-day fashion. And of course, like many NSF centers, we are very involved in the dissemination and development of best practices and exceptional curricula. We've hosted a number of workshops in the past year, and I'm glad to talk about some of the ones that are on the radar for this coming year. When you have a chance, please go to YouTube. You'll see some of our past webinars. Here you'll see, go back. The basics of HVAC program accreditation was our first. Then later we talked about credentialing and certification. Our most recent webinar is Campus as a Living Lab. That was done in November in conjunction with the Seed Center. And you'll be hearing references to that as we go through this PowerPoint. bestcte.org is our prototype website. We have a new one under construction, so please come back and visit. Dean Peter Crabtree is the PI for the center over at Laney, and you'll see his contact info there. Okay, today, besides myself, our co-PI Brian Lovell, who's over in Georgia, will be our co-presenter today. He's the founder of the Building Automation Program at Georgia Piedmont Technical College, one of the first building automation programs based at the community college, and is currently co-owner of the Watt Doctors. So what is building automation? I think as the name implies, it is the automated control of building systems such as lighting, HVAC, and security, used to optimize comfort, safety, and energy management. Right? Current automated technology really is very akin to a computer network that you'll find in many offices and industries. Right? We're utilizing a network of sensors, controllers, actuators, right, and computers, right, that basically exchange information. And sometimes you'll hear the terms BAS, Building Automation Systems. That's the kind of shorthand I'll be using today. Sometimes it's referred to as building management systems, other times as energy management systems. And yeah, there are nuanced differences between all of those. Yeah, did you have a question?
You see the use of deterministic type networks in building networking devices versus non-deterministic TCP/IP or IP-based, or are they going the way of wireless and IP-based networks?
Well, you'll definitely see as we move through BAS architecture, right, the use of TCP as well as wireless. I'm going to let Brian Lovell talk more about some of those kind of technical details. No worries, no worries. No, thank you for your question. Right. There are definitely commercial and residential applications. The BEST Center is focused primarily on commercial applications. Right. We've got huge buildings that use vast quantities of energy. Commercial buildings use about half of the electricity, residential making up the other half. Right, and of course, many of you are already familiar with the phrase programmable logic controllers used in automated manufacturing processes. Okay. Let's go back. So, looking at the evolution of controls. Right, on the left, you'll see a pneumatic system, which is basically using the medium of compressed air via a series of tubes, right, that transmit information to regulate mechanical movement, right, in old-fashioned gauges. And then we have morphed over to direct digital controls, using electrical and digital signals here to control our system parameters. You know, what you'll also find in many buildings is that these pneumatics, right, are still very much in use in many buildings. To remove those can be very, very expensive. And in fact, you'll see DDCs piggybacking on pneumatics as a way of transitioning the system so that way it can provide more pertinent data. Right, so just as an example here of how this is applied, right, building automation really is the convergence of building and information technology. An example here in this diagram is how it's applied to an air handling unit. And for those of you who may not be familiar with that term, I think of the air handling unit as a box with a fan, heating and cooling coils, a filter, right? And that is basically the instrument which takes air, right, and delivers it throughout a building to some desired set temperature. Right. As you'll see here, right, we have a temperature sensor, right, that sends information back to a field panel, right. This controller then can look at this and determine then what is the appropriate action, right, send a signal to an actuator, right. This data then is transferred to a workstation, right, one that an operator or facilities manager might typically use. Then the information can then be sent to the internet and then accessed remotely from a variety of mobile devices. So why building automation? I think probably the term smart and intelligent buildings have become very, very pervasive. You see commercials now, right, Comcast and others talking about the digital life and, you know, controlling your home systems remotely. right? But they are dynamic and adaptable environments, right? Kind of leading us out of kind of the building as this sort of static object. There is certainly the potential to create an integrated communications network, right? Versus looking at very disparate and kind of siloed approaches, right? Where you may have one building or many buildings then finally interconnected, right? And that's a tremendous benefit when you're, say, someone who's managing a campus of buildings rather than kind of running around from building to building. Now you can begin to pull all that distributed information and to be able to view it more easily, right? Now, again, talking about facilities management and preventive maintenance, right, one of the great benefits here is of reduced life cycle costs, right? So as an example, right, if you're able to operate equipment more effectively per spec, right, then you are less likely to have to replace that equipment, right? So there's a savings right there. I mean, frequently motors have to get replaced. The next item here, of course, the potential for energy savings. That's the huge motivator for many building owners, right? Being able to monitor your building's performance, right, to utilize building diagnostics through data collection and analytics, right, and then to finally develop a plan of optimization, right? And one example for commercial buildings is something called demand response, right there. Demand response is typically done in conjunction with an electric utility, right, whereby there is a strategy for load shedding, trying to reduce a building's energy usage during peak periods, right? And of course, that is when you get charged your highest rates, right? And a building automation system can interact with a utility smart grid system, right, to create an automated demand response network. And finally, but certainly not least of all, is the potential here for climate and environmental mitigation, right? It's our mission here as part of the BEST Center, right, to promote energy management as a means for contributing to the reduction of greenhouse gases and electricity usage. Pretty astounding statistic, right? Buildings account for nearly 40% of U.S. greenhouse gas emissions and 70% of electricity usage. And again, commercial buildings figure out about half of that. All right. And just briefly, looking at the potential for employment. All right, this was the result of a down and dirty survey that was done here in the Bay Area. Done in 2012. We were assisted by Mount San Antonio College down in Walnut. They also have a building automation program, grant-driven, a one-year program. And these are just very, very telling responses in terms of projected growth. Right, the companies that responded here all said they anticipate that they'll see growth in their contracts. Right, the top three responses are 250%, 50%, and a 30% increase in business. Right, almost all of them responded that no, we don't have enough technicians. Right, how many do they anticipate hiring in the next 5 years? You'll see the responses 25, 20, and 10. And again, keep in mind this was like a very kind of quick taking of the pulse here. And why do you need more technicians? Right? Again, to respond to business growth. And what are some of the desirable entry-level skills? Right? Again, almost all of them felt that entry-level building automation technicians, or those applying to become those technicians, were not really equipped, right? What skill level would be ideal here? at entry. And you can see that at a more advanced level, they're really interested in the candidate being able to understand networking of devices, energy management, as well as installation of the network. At an intermediate level, right, having skills and knowledge in HVAC and plant operations were also cited. Here's one comment that really stood out, right? We need technicians that are experienced in programming and commissioning the latest digital controls. And also a need for to go to programming.
When you say, so they want more traditional computer-based programming? Or you're talking about programming of the equipment, PLC?
Programming of the equipment.
Okay.
Like Allen Bradley.
Yeah.
Oh, okay.
Or I can't remember, it's like a Wonderware product where it's object-oriented, your devices, your valves, you drop them on the screen. You got to understand
You'll see that.
the relationship
Right.
between that and the equipment.
Right. And Brian will be talking about block programming.
Today, we can go over that today? In this session?
Yeah.
Oh.
Yeah. Just a brief overview. Yeah. Again, and then in terms of education and hiring, right, to what degree would having a certificate influence their decision to hire, strong and moderate? Where do they recruit these technicians from, right? Well, we hear this time and time again from our competitors, right, because there's no pipeline that's readily available. It's taking time to, again, get these students out into the workforce. So they're rating from each other, but you also see they go to 4 years looking for candidates coming from CIS or engineering programs, but then at the community college level, having an HVAC background is definitely a plus, right? And then finally, what can we do to really support the growth of this industry, right? We need more trained personnel because, again, they have a lot of unskilled people filling in, having to do a lot of on-the-job training or sending them out for more additional training. And now I'm going to turn over the presentation to Brian Lovell, who will talk more about the curriculum development. Go ahead, Brian.
Okay, can you hear me okay?
Yeah, just fine.
All righty. Hopefully, if you start getting any feedback, just let me know and I'll turn my speaker down. But my name is Brian Lovell, and I'm happy to join you today to talk about building automation systems. My background has been in the automation world as a contractor for 15 years, and then joining a technical college to develop the curriculum that we'll talk about in just a second, centered on building automation. And then subsequently to that, now of course, Larry mentioned I work with the National Science Foundation and the American Association of Community Colleges to seed programs around the country that are centered on building automation systems and develop teaching capacity because of the need, as Larry mentioned, for technicians in the industry. And so, first off, this program, the last 6 years, when I was with the technical college system, we developed a program of study at the associate's degree level, a 2-year level, that addressed this need for building automation technicians in the Atlanta metro area. I think Larry mentioned the need for technicians in San Francisco. It's very much the same in the Atlanta area. When I had my business, one of the chief hurdles to growing that business as we gained more contracts was finding enough qualified technicians, because you could hire an IT professional, you could hire an HVAC professional, you could hire an engineer, but in the automation world, you need a little bit of each one of those skills and more to be successful. So I never could, when I was a business owner, find somebody coming out of college with the skill sets requisite to being successful in the industry without providing them a lot of training. So in 2007, we addressed that need in the technical college system of Georgia by developing a program with specific outcomes that would prepare a student to gain entry-level employment within the automation industry. The knowledge, skills, and abilities, the slide that you're looking at now, are the basic headings of the areas we thought that they needed to be proficient in. And of course, there are many outcomes, learning outcomes, underneath each one of those headings, which we don't have time to go into. But And then we tried to see the entry points as well. The entry points, we pretty much in the state of Georgia have to accept most any student coming out of high school. So what we would encourage them to have is an aptitude for troubleshooting or analytical thinking, and of course basic computer skills and familiarity, which they will need in the industry. By the time they'd finish the program, the areas we would focus on give them a good foundation in heating, ventilation, and air conditioning principles and building systems. While Larry mentioned air handling units are quite simple, it turns out in commercial buildings they become extremely complex as far as how they're controlled, and the implications of energy usage if they're not controlled properly to a sequence of operation can be astounding. Electrical circuits and troubleshooting, students or graduates of this program have to be very familiar with using an electrical meter, and the reason for that is automation systems basically boil down to a decision-making device, electronic device, which takes specific inputs and then generates a control response or an output. And fortunately, those inputs are standardized to about 5 or 6 standard physical inputs that the students have to be able to wire, have to be able to check with their meters, and have to be able to calibrate, and about 3 to 4 different types of outputs that are commonly encountered. That could be 0 to 10 volts DC, it could be an analog output, just a digital on-off, turn on and off a device, a switch, light, circuit, or whatever. The variance really comes in the software itself, which we'll talk about in just a few minutes. Another key area is building systems sequences of operation. Buildings today are more complex than ever. You have not just the HVAC systems to control, but you have daylighting, reducing lighting levels in spaces based on ambient lighting coming in from the outside, which USGBC really encourages using things like that for energy savings, and so that just adds to the sequences of operation of a building. And you're seeing a lot more access controls, lighting controls, security controls, card access, etc., running through the building automation system these days. DDC, direct digital controls, input and output wiring, the standard inputs and outputs that we just discussed. Installation techniques for how you mount, where you mount, and how you mount and terminate wires to automation systems. Just as in the IT world, where it's so critical to get good terminations to prevent collisions and reflections on the network, it's very analogous to the controls world. One of the chief problems with controls is that they don't consistently get the wires don't get consistently stripped back and terminated to the right torque, and without that consistency you end up with short circuits, or you end up with communication problems, etc. Control theory and application. This goes back to how do you control a device for optimal energy savings and for limiting the wear on a piece of equipment. Let's take a heating valve, for instance, that has a various number of positions. It could take from 10% open to 20% open to 30% open. Well, you have to have an understanding that there's an optimal position that valve should take at any point in time to provide just the right amount of heating. Where in the past, it may have been, before the advent of DDC controls, it may have been opening for a little while and then closing for a little while, and then when there was another call for heating, it would open again. Well, you can imagine the amount of mechanical wear that device would incur based on that kind of control strategy. Network communications is becoming, and we'll touch on this more in the next slide, a huge area in automation systems, and it's an area that a lot of existing technicians are not well versed in. I heard a question earlier about is the industry going IP, Internet Protocol? Absolutely. We'll see a diagram, a network architecture diagram in just a minute here. Information now, automation systems are really just becoming more nodes on the network, because building owners and managers are demanding information from their buildings based on performance that they've never done before. Used to be the realm of facilities managers, of maintenance men, who were mostly concerned with, are we providing enough heat, or providing enough cooling, are people comfortable? Now the questions being asked, are people comfortable, and are we running our building optimally as far as efficiency? Because utility prices are going up, and we can compare our building against other buildings to see how much energy is being used per square foot. Why is our building using twice as much as another building of similar size and usage? Those kind of questions are being driven by the access to information over computer networks. Programming and commissioning, that's another key area. I heard another gentleman mention what type of programming do you run into? Is it object-oriented? Is it block or whatever? In our program, we introduce, in the beginning of that course, we use the Alice software that was developed at Carnegie Mellon to introduce students to the principles of object-oriented programming and instances of classes, and how each object has particular attributes that you can change and modify as you're developing a control strategy. Commissioning is also a very large area in this industry now, that building owners want to make sure that their equipment is started up properly, and it's started up and checked out to make sure that everything is calibrated and working at peak efficiency. And that's becoming another career pathway within the automation industry itself. And then finally, DDC integration. There's been a strong push and drive towards interoperability and communication between disparate systems. When I first started in the automation industry in the early 90s, 92, 93, there was very little of that. It was all proprietary. You would dial into a modem at, back then maybe 9,600 bits per second. You would get into the main controller, the supervisory controller, and under that controller you'd have an RS-45 network communicating at perhaps 38.4 kbps, kilobits per second. And that was considered state-of-the-art. Well, today, you just get into your web controls and you query your panels, and all that information comes back over TCP/IP network. It's stored on the web. The industry has changed completely from what it was years ago. And I'll try to advance this slide. I can't do that. Could you advance the slide for me, please? Thank you. So there are a number of KSAs related specifically to the building automation industry. I won't go through all those. I wanted to focus on the ones related to the IT industry that could easily be implemented within an existing ICT program. For the data DEC network communications, we follow the CompTIA Network Plus book, which I'm sure you're all familiar with. And we go from chapter 1 through about 2/3 of that book. And what that does for our students, it gives them the lingo of the IT industry. It gives them an understanding of things like the OSI model and layers of networking, from the data link layer all the way up to applications. It gives them an idea of physical media and the types of things that they'll be running into when they start terminating these controls and working with IT professionals to make sure that everything is communicating properly. For DDC programming and commissioning, again, we use Java as the base language which we instruct students on. We start with Alice, then we talk about the principles of programming, and then we get into Java and the object-oriented programming. And we don't go very far in that. We get them to the point where they can understand the various types of loops, you know, do-while loops or if-then-else loops or while-when loops, etc. And then write basic programs, because at the end of the day, every control system, while they may communicate and be integrated together, they still have proprietary means for which you program each particular controller and control system. I heard somebody mention Wonderware and Allen Bradley. Those are primarily found in the industrial marketplace, while in the commercial HVAC marketplace, you run into the Johnson controls, the Siemens, the Delta controls, etc. And at that level, at the programming level, none of the systems communicate. They may have similar objects or standardized objects within their programming schema, but each one programs their controllers their own software. So it's a disservice to the students to focus on one system over another. That's why we chose Java. I know that Java is used by Tritium, which is a company that's its sole existence is to integrate and overlay control systems so that information is accessible via web page over disparate systems. So you could have a Siemens, a Honeywell, a Johnson Controls, and you could see all the data from all your buildings on one web page using Tritium. Well, that has been, to this point, Java-based. That's why we selected the Java programming language. And then the DDC integration, where we talk about protocols of communication like BACnet and LawnWorks and Modbus and others, which we'll touch on in just a second here briefly. I know I'm running out of time. Could you advance the slide, please? Thank you. I've put up two network control architecture diagrams for you, and this was courtesy of DDC Online. So you can look at most of the major equipment manufacturers' network architecture diagrams. They all do it a little bit differently. In the one on the left, you see the Delta Orca system that stands for Open Real-Time Control Architecture. And then on the right, you see the Distech controls, the ECNet solution controls that they have. It turns out both of these companies are Canadian. Delta Controls is on the West Coast in Vancouver, and Distech Controls is manufactured in Montreal. I didn't realize that until I put them on the slide. So if there are any Canadians in the audience, it wasn't by choice, but I'm sure you're very proud right now of those two selections. But if you look closely, I don't know if you can see it. It may be kind of small, but you have the primary internet protocol, TCP/IP level, where you see on the Delta controls, they use BACnet, which is the Building Automation Controls Network Communications Protocol, which was initially developed by ASHRAE and is now an ANSI and ISO standard. That is very prevalent in the industry. Okay, so that can communicate over various types of media, and it has 50 standardized objects, where if you're BACnet compliant in Delta controls, you would have the same 50 objects that you would have, let's say, in a Distech control system that's also BACnet compliant. So when you get to that level right there, you can pass packets right across the internet. Now, as you go down in the network architecture, you'll see that you get to a peer-to-peer level where you have the supervisory controllers, and it's running BACnet over Ethernet. That's just communicating between the controllers themselves using Ethernet as the media. And below that, you have a secondary network, which might be master-slave token passing BACnet, or it could be something else running at the RS-45 level, where you're handling each air handling unit would have its own controller that is on that network, the secondary network in the Delta controls architecture. Similarly, in the Distech controls, you have the highest level, and that could be BACnet IP, HTTP, extensible markup language. They have several options there. And then on their primary network, I think they run LawnWorks. I can't really see on my screen, but I think they run LawnWorks there, and below it's all LAN, or peer, which is another control protocol, which is a standard in the industry, a competing standard to BACnet. That was developed by the Echelon Corporation in the late 90s. And LawnWorks and BACnet for years were pretty much equal market share. BACnet has taken now a lead and is more favored, but then LawnWorks is the standard in China. So, and for some industries like train controls now, and others use strictly LawnWorks. So a lot of technicians will run into either one of those two protocols, and there are others as well. Next slide, please. Briefly, I'm just showing a couple of slides here of the type of programming that students could get involved with. Some systems use just standard line code programming, or visual programming with objects. You know, this is just the idea here is that students need to be able to set up a modular style program to call subroutines and to be able to execute basic logic and set up with standard programming indenture so it's readable and lots of REM statements so that they can remember what they did and what they set up originally. Now this oftentimes these days is the purview of an IT professional coming out of college who's given a particular thing that controller needs to do and given a sheet that describes all the things it needs to do. They'll write the program in the office. Before that program is applied to mechanical equipment, it's checked in the office and then it's downloaded into a controller itself. So there's a divergence now of skills that's becoming so great that a lot of companies, a lot of controls companies in the Atlanta area are hiring IT professionals coming out with a 2-year or 4-year programming degree and keeping them busy writing code to support automation controllers. This is beyond the capability of most HVAC control technicians because even to this day, most of the controls technicians out there that are installing equipment do not have that kind of pedigree of experience to programming languages. Next slide, please. Other companies, this is an Automated Logic's ICON system, use blocks, and this looks a lot like objects that would have various properties, and you could interpret it as such. But this was designed more for old pneumatic technicians who were used to running air pressure pneumatic lines between various devices that would control or receive an input and would control an output with varying air pressure. And so they came up with this software, and these block diagrams, it's just like Visio or AutoCAD. You just draw a line between one input and a controller and then your set points and then an output. And I've seen these block diagrams go pages and pages and pages long. Some people like this better. My preference has always been just the code, line code programming that's easy to print out. Others who have a different background may prefer this kind of software, but I just wanted to show you that this is out there as another type and way of programming automation systems. Next slide, please. Okay, I'm going to go through this really quick. Okay, that's an older slide. Okay, so in this slide, this just shows the layout of courses in the Georgia Piedmont Technical College curriculum. You see the general education classes at the very top. We then introduce students to the HVAC principles and electrical principles. And then at the end of year 1, beginning of year 2, we start introducing them to, you'll see BUAS 1050. Network architecture. That's based on the Network Plus certification from CompTIA. And then in the second year, that's where we hit the BAS programming and logic, the BAS integration, the design and installation. And then in the internship and the integration course, students go from start to finish with designing an automation system, installing it, and then programming it and commissioning it. And without a doubt, that's where the real complexity comes in programming these controllers properly and then commissioning them and making sure that they're working the way that they should work. Next slide, please. And I'll finish up here. Here are just some pictures of our laboratory, students working on some of the benches, setting up some application-specific controllers at that lower secondary network level. On the right side, top picture, those are some Siemens application-specific controllers and all the associated devices which students control on the workbench, and then they'll program the controllers and then start them up and check them out. And then in the bottom right, this is where students were designing just a digital relay adding machine that turned out to be an 8-bit adder that was all run by digital logic with relays, and that provided some hands-on experience with just gave them some basic analytical and electrical experience using meters and checking out those relays, etc. And I think that's it for me.
just quickly, since we're in time here, I'll provide through what we're knowledge, right? And this is the course sequence for our BAS program, and it is a spin-off from our commercial HVAC program, which is a 2-year sequence, right? This is, again, another 2-year sequence. You'll see in the first semester, right, that we want to provide a solid foundation in building science, math, and electricity. We really feel that it's extremely important that our technicians be able to grasp fundamentals of heat transfer, thermodynamics, psychrometrics. In the second semester, you'll see the introduction of the commercial HVAC courses right there, as well as direct digital controls and the hardware for building automation systems. And by third semester, right, more advanced courses in control system designs and networking. Right? ICT 27 is where we introduce the students to some very basic programming methods here. And then by fourth semester, they wrap up really looking at integration and following a lot of the things that Brian just mentioned about interoperability between different types of protocol-driven devices. We also think it's important for students to be aware of energy issues and policies, right? Understanding that there is this very strong interrelationship between setting up requirements for building performance and then expediting on those requirements. And then ICT 29 is where we get into data analytics. And our students not only look at using an energy management system for retrieving information, but they actually, when the opportunity is available, they go out in the field into a real building. They locate data loggers, devices that record information over some time frame. They collect that data, download it, and translate that into graphs, so that way an assessment can be made, leading to recommended methods of optimization. And just a brief glimpse at our lab. It's really tremendous to have a commercial HVAC lab at our disposal. Right, you'll see right here that we have, as part of a hydronic system, right, a commercial boiler and chiller operating on variable frequency drive. That is, the VFD is one of those energy savings devices. So machinery doesn't have to be simply in an on-off mode, right? Just think about a light dimmer, right? Now you've got a lot more flexibility. They are interconnected with our very own cooling tower. Again, not part of the campus's active cooling tower system. This is purely for lab demos, right? And likewise, we have a series of air handling units, commercial type ductwork. Here you see a student working on a variable air volume box. That is another energy efficiency device, which allows for zone control of occupancy comfort. And then finally, you see some students here working on some DDC trainers. And initially, the students actually helped to construct these trainers. Again, another great hands-on opportunity. And then in terms of how controls are integrated into our lab, you'll see in this diagram, the controls network was designed by Facility Dynamics here in the Bay Area, right? But to the left, here are a number of field panels, all connected to a variety of the VAV boxes you saw on the previous slide, right? And this young lady here is working inside one of these multi-vendor panels. Again, we don't want to have students focused only on one manufacturer, one way of doing things. This really gives them the means by which they can compare how various systems are similar or contrast with each other. Right. And So we'll wrap up here. Brian, do you want to talk about the opportunities for ICT programs and the instructors?
Sure. I'm sorry, I had to turn my volume down. Can you hear me okay? Okay. There are many opportunities for ICT programs in offering BAS courses and/or even developing a major based around building automation systems. ICT students, the first line there, can bring important skills to a BAS program. The BAS industry is becoming more and more aligned, and you could even argue more so aligned today with the IT industry than it is with the HVAC industry, in which it was really born initially. Controls initially were a subheading in the new construction project under Division 15 of work, which was always the mechanical division of work, because typically the most complex sequences of operation in a building were found in HVAC equipment. And so controls systems were designed to handle those and control heating and cooling to a building, etc. Well, starting 10 years ago, and even more so now you have control systems that really are just nodes on a network and have tendrils into the access control systems, security systems, etc., etc. And with all that data passing and networks, in the future, you're going to see even more of a migration and connection between the IT world and the building automation systems world itself. Career pathways, new career pathways for ICT students. A student with the basic understanding of networking and how packets are passed and all that kind of stuff and application software, tremendous advantage for building automation systems companies. You're talking about today a $15 billion industry, which still does not have a standard for a credentialing standard for technicians coming into the industry. But almost every building automation systems company you would talk to says that a prerequisite of becoming a building automation systems technician today is a solid background in IT. Even if you're not going to be setting up the networks, you're going to have to talk to a network administrator. And if you don't understand basic terminology and basic IT lingo, how likely is it that that network administrator is going to give you access to his network or her network and allow you to get in there and do your thing if you can't even speak the lingo? So it's a requisite skill set these days. Working with building automation and controls companies in your local area, these companies are so motivated to find and source employees that, well, just recently, a few months ago, Siemens Corporation flew up 50 instructors from technical colleges around the country and facilities directors to St. Clair Community College in Michigan. Took care of all the expenses, took care of all the food, everything, because they're trying to get, it's not just them, Honeywell is doing the same thing, Trane Corporation is doing the same thing, Honeywell will probably do one in California this year, and it was really to encourage and to find programs around the country that are willing to add building automation systems courses, because this industry is just growing. Even during the recession, it's just been growing geometrically over the past several years. Working with other departments, this helps break down, programs like this help break down silos between divisions of the college and even divisions of training within the college. Like in our college, the program was founded initially, the BAS program was founded in the industrial area. Well, as we started to blossom and grow, the IT division also started working with the HVAC division, and it kind of broke down some of those silos. Developing a BAS program or BAS track within the current ICT curriculum just increases the chance that your students are going to find employment opportunities on graduation. And then another key thing is real-world projects that students in your IT programs can learn on. Now it's not just setting up you know, a network within the laboratory. Now, since they're dealing with nodes on devices from the automation system on the campus itself, if you work with an automation company that's servicing that building, they can give you a web page and send and route all those packets to your IT students, and they could actually be monitoring building performance. So you turn what sometimes can be kind of esoteric book knowledge into real-world projects on your campus that make the campus actually more efficient, and students can have a hand in that. So a lot of advantages there, and I'll stop there.
Yeah, so Carla, we're just about done here. In terms of opportunities for any of you, right? We've hosted workshops previously. We had our very first Best Center workshop at Georgia Piedmont, looking at the establishment, development of the building automation program, what it takes to get institutional support for such a program, right? You know, work with us in case you're considering something along these lines, you know, whether it's a track within an ICT program or a standalone program, right? In the past, our workshops have run about 2.5 days long. We can provide some travel stipends, and the workshop materials are also available on our website. Okay. Finally, this is George Judson's recommended reading list, right, online. I think a number of these are kind of self-explanatory, but really a great way to get started. You know, Automated Buildings is a great site I like to go to for just a wide array of articles, looking at both education, movements in the industry. DVC Online is a great place to look at an introduction to direct digital controls. And with that, we want all of you to remember to turn off the lights, turn it off when you're not using it, and remember to get in touch with us if this is something you want to pursue further. Thanks very much. I think we're probably out of time.
Yeah.
I'm glad to take any questions.
Yeah, we can take questions afterwards. We're going to have to get the other group in, but thank you very much, Brian, Larry. You guys did a great job.